Okay, so question number 5 says, suppose the charge of a proton and an electron differ slightly. Okay, let's say this is a hypothetical situation that maybe the charge of a proton and electron inside the atom differ slightly. One of them is negative E and the other one is E plus E. Okay, this is the condition, one is negative, one is E plus E. So delta E jo hai, that is your slightly change. If the net of electrostatic force and gravitational force between the two hydrogen atom placed at a distance of d much greater than the atomic size apart is 0, then delta E is of the order what? Okay, let me explain you first question, then we'll go for the solution. So question says that the charge on a proton and electron is differing slightly, and if you take two hydrogen atoms, what is a hydrogen atom? The first period, the element in the first element of the periodic table, and it has one electron in the outermost shell. Okay, and nuclei contains one. Now I am not assuming isotopes here, right? So I am assuming one proton is there, single proton, and around which the electrons are revolving, right? Now in that case, if the charge is differing by a slight value, what will be the ratio of gravitational to electrostatic force, provided they have given that this is 0. Okay, you can see here, so this apart is 0, we can see. Okay, so let's start with question, and as I will solve, you will understand it better. So first thing, if there is a slight change in the charge of an electron and a proton, clear? So if there is a slight change, then what is the new charge? New, previously what? Okay, let's take the previous case. In the previous case, man, there is no change. We know that hydrogen atom, there is a nuclei in which there is a proton and an electron is revolving around. So what is the overall charge of an atom? 0. Because we know that charge of a proton is positive 1.6 into 10 raised to minus 19 and electron is negative 1.6 into 10 raised to minus 19. So atom as a whole, all the atoms are neutral as a whole because the number of electrons are equal to number of protons, right? Coming back to this, now the problem is saying that we have a differing charge. So in that case, the new charge of this hydrogen atom we have to calculate. So new charge on one hydrogen atom, that will be how much? Q, and that Q will be equals to minus E, that will be the new charge on electron, plus the protonic charge which is differing by delta E, right? Previously this delta E was not there, so that's why it was neutral, but because of this delta E, the new charge will be delta E. This is the overall charge of a new hydrogen atom, right? So what will be the repulsive, or what will be the repulsive force acting between two hydrogen atoms? So let's imagine the scenario. This is our hydrogen atom, new hydrogen atom with delta E overall charge, another hydrogen atom with new delta E charge. What will be? They will attract or repel? They will repel. Why? Because the charges are of same polarity, right? So force of repulsion Fr will be equals to K Q square. Q square is delta E. I am not putting the value of K. Maybe at the end we will cancel out, okay, whole divided by the separation. So let's call this separation as D, okay, because they have not mentioned the separation. Okay, now they are saying they have mentioned if the net of electrostatic force and gravitational force between the two hydrogen atom placed at a distance d, right? So both have a separation, same separation, right, for gravitational as well as electrostatic. So let me just keep it as equation 1. Okay, great. Let's move ahead. And what will be our gravitational force between the two? So let me remind you from class 11. Gravitational force is G, M1, M2. Both will have same mass, right? Nothing. You are not changing the configuration. Hydrogen atoms are there. Only you are changing the charges, right? So mass M square upon the separation square, D square. Correct. This is our equation 2. Given here mass of hydrogen atom is 1.6 into 10 raised to minus 27 kg in the problem. So we will make use of this at the end, right? So here, if the resultant is 0, we can say that Fr, both are equal and opposite. So this will be Fr equal to Fg, and Fr is nothing but R. You can take repulsive force, okay? So don't get confused. You can write electric force also. Fe doesn't make any difference, okay? That is just a notation. So this will be K delta E whole square upon D square, and the gravitational force is G M square upon D square. Now is there anything which is cancelling out? Yes, of course, D is cancelling out. Rest are constants. Let's plug in the values. So delta E is the charge whole square equals to g. Let me remind you, this is from 11th standard, 6.67 into 10 raised to minus 11 into mass square. Mass is just now given in the problem, that is 1.67 into 10 raised to minus 27 kg whole square, whole divided by k. K is 9 into 10 to the power 9, correct? Okay, we can further simplify it. So this will be our 6.67 into 10 raised to minus 11 into let me multiply 1.67 into 1.67, that will give me 2.7889 into 10 to the power minus 54 whole divided by 9 into 10 to the power 9. Great. So let me first simplify the magnitudes. So 6.67 into 2.7889 divided by 9, that will give you nearly 2.0668 into let me simplify 10 to the power 11 and 54, that will be how much? 65 minus 9, that will be minus 56. So 10 to the power minus 56, that will be our delta E square. Let's simplify it further. So here if we take the root of 2.0668, that will give us nearly 1.437, okay, and into 10 to the power minus 56, that will give you how much? Divided by 2, that's nearly 10 to the power minus 28. Let me just reconfirm these values. So here 6.67 and that is 27, okay, so 27 into 2 is equals to 54 minus 54 and minus 11, that will give you, okay, minus 54 and minus 11, that will give you minus 65, and minus 65 and 9, that will give you minus 56. So correct answer is 10 to the power nearly minus 28, correct? So nearly 10 to the power minus 28, that is our delta E. Okay, so here there is slight variation. I have, let me just, because the 4 options are not same, so let me just check if I have gone through a mistake somewhere. 6.67 into 1.67 into 1.67 whole divided by 9. So this is 2.066 and this will be minus 54, that is correct. So there is a slight typing mistake, it is 10 to the power minus 28. So correct answer must be 10 to the power minus 28, because if you take the root of this 56, okay, that will give us minus 28. That's our correct answer. So correct option is option, let's make it B, okay, let's make it is 10 to the power minus 28. So this is the power, okay, magnitude wise you can keep it 1.437, but they are asking in order. If you read the question carefully, they are asking what will be the order of this delta E, okay. Delta is of the order of 10 to the power minus 28.